Download this code from codegib.com, link in the description below. OK, let's dive into configuring topic auto creation with debezium UI, complete with detailed explanations and practical examples. This is a powerful feature that streamlines your data streaming pipeline, especially when dealing with dynamic schemas and evolving data sources. What is topic auto creation and why is it important? In a debezium-based change data capture (CDC) setup, debezium captures changes from your source database, example mysql, postgresql, mongodb, and publishes these changes as events to Kafka topics. Traditionally, you'd need to manually create these Kafka topics before debezium could start streaming data. Topic auto creation, as the name suggests, automates this process. When debezium detects a new table or database being tracked, it can automatically create a corresponding Kafka topic with appropriate configurations. This eliminates the need for manual intervention and significantly reduces the operational overhead of maintaining your CDC pipeline. Benefits of topic auto creation * reduced manual effort * no more manually creating Kafka topics for each new table. * faster onboarding * quickly ingest data from new sources without requiring a separate topic creation step. * dynamic schema evolution * handles situations where your database schemas change frequently, example adding new tables or columns. * simplified management * easier to manage and scale your CDC infrastructure. * consistency * ensures that all debezium created topics adhere to a predefined set of configurations. Prerequisites * Kafka cluster * a running Kafka cluster is essential. You'll need the address of your Kafka brokers, example localhost 9092. Debezium UI * you need to have the debezium UI deployed and accessible. This guide assumes you have it set up. Debezium connector * a debezium connector, example mysql connector, postgresql connector, deployed in your Kafka Connect cluster. Kafka Connect cluster * a running Kafka Connect cluster that debezium connectors are deployed in. Access to Kafka configuration * you'll need administrative access to your Kafka cluster to configure broker settings. Steps to configure topic auto creation with debezium UI. The process involves two main parts. 1. Configuring Kafka brokers for auto topic creation * you need to enable and configure the auto.create.topics.enable property on your Kafka brokers. 2. Setting up debezium connector properties * you'll configure the debezium connector with the necessary settings to leverage the auto creation feature. Step 1. Configuring Kafka brokers for auto topic creation. This is the most crucial step. If Kafka isn't configured to allow auto topic creation, debezium won't be able to create topics automatically, even if the connector is configured correctly. 1. Access your Kafka broker configuration files. The location of these files depends on how you deployed Kafka. Typically, they are located in the config directory of your Kafka installation. You'll need to modify the server.properties file, or equivalent configuration file for each broker. 2. Edit the server.properties file * add or modify the following property. This line enables auto topic creation. By default, auto.create.topics.enable is usually set to true in some Kafka distributions, but it's best to explicitly set it. 3. Optionally, configure default topic settings * you can also configure default values that will be used for automatically created topics. Here are some common properties. Important considerations for production ****. Replication factor * in a production environment, always use a replication factor of 3, or higher, depending on your fault tolerance requirements, for reliability. A replication factor of 1 means you have no redundancy, and if that broker fails, you'll lose data. Number of partitions * consider the expected throughput and parallelism requirements of your topics when setting the number of partitions. More partitions generally increase throughput, but also increase overhead. It's best to start with a reasonable number and monitor performance, adjusting as needed. You can't easily change the number of partitions later without data migration. *min in sync.replicas, configure this property based on your data durability requirements. It represents the minimum number of replicas that must acknowledge a write operation before the leader broker considers the write successful. A higher value increases durability but reduces write availability. For restart Kafka brokers * after making the changes to server.properties, you must restart all Kafka brokers in your cluster for the new configuration to take effect. Use the appropriate restart commands for your Kafka deployment environment. Important * restart brokers one at a time, rolling restart, in a production environment to minimize downtime. Step 2. Configuring debezium connector properties using the debezium UI. Now that Kafka is set up to allow auto topic creation, you need to configure your debezium connector accordingly. The debezium UI simplifies this process. 1. Access the debezium UI *, open your web browser and navigate to the URL where the debezium UI is running. 2. Create or edit a connector *. If you're creating a new connector, click the Add Connector button. If you're editing an existing connector, find it in the list of connectors and click the Edit, or equivalent, button. 3. Configure the required connector properties *. You'll need to configure the usual connector properties like *connector.class, the class name of the debezium connector you're using, example io.debezium.connector.mysql.mysql connector. *database.hostname, the hostname or IP address of your source database server. *database.port, the port number of your database server. *database.user, the username for connecting to your database. *database.password, the password for connecting to your database. *database.server.id, a unique identifier for the debezium connector. *database.server.name, a logical name for the database server that will be used as a prefix in the Kafka topic names. *database.names, the database names to be monitored. *table.include.list, an optional list of tables to be monitored. If not set, all tables within the specified databases will be monitored. *topic.prefix, prefix for the Kafka topic names created by the connector. *key.converter, converter for Kafka key serialization/deserialization. A common setting is org.apache.kafka.connect.json.json converter. *value.converter, converter for Kafka value serialization/deserialization. A common setting is org.apache.kafka.connect.json.json converter. *key.converter.schemas.enable, set to false or true, depending on if you want the schema information to be included in the message key. *value.converter.schemas.enable, set to false or true, depending on if you want the schema information to be included in the message value. *offset.storage.topic, the Kafka topic where connector offsets are stored. *offset.storage.replication.factor, replication factor for the offset storage topic. *offset.flush.interval.ms, how often to flush offsets to the storage topic. 4 properties related to auto topic creation, less critical in modern debezium versions. In older versions of debezium, there used to be properties such as topic.creation.enable and topic.creation.default*. However, these are often deprecated or unnecessary in more recent versions. Debezium now relies more directly on the Kafka broker's auto.create.topics.enable setting. In the Debezium UI, you may still see these properties. If they are present, ensure they are set as follows. If they are not present, that is generally fine. The Kafka broker's setting is now the primary control. *topic.creation.enable equals true, if present. *topic.creation.default.partitions equals 1, if present. *topic.creation.default.replication.factor equals 1, or higher for production, if present. 5 Important configuration example. Here's a simplified example using the Debezium UI, assuming you're connecting to a MySQL database. Explanation *connector.class specifies that we're using the MySQL connector. *database connection details for your MySQL database. *database.server.name, a logical name for your database. This name is used in the topic name, example your_cdc_prefix.your_mysql_server.your_table_name. *topic.prefix, a prefix for all Kafka topics created by this connector, example your_cdc_prefix. *table.include.list, a comma-separated list of tables to capture changes from. Use regular expressions for more complex inclusion/exclusion rules. 6 Save and deploy the connector *. Once you've configured all the necessary properties, save the connector configuration in the Debezium UI. The UI will then send the configuration to your Kafka Connect cluster, which will deploy and start the Debezium connector. Step 3, Verify topic auto creation. Once start the connector *, ensure the connector is running successfully in the Debezium UI. Check the logs for any errors. 2 Create a new table, or add data to an existing table in your source database. Create a new table that matches the table.include.list, or add data if using an existing table. 3 Check Kafka * use a Kafka consumer, example Kafka console consumer.sh from the Kafka distribution, Kafka UI, or a custom application, to verify that a new Kafka topic has been automatically created for the new table and that change events are being published to that topic. The topic name will typically follow the pattern. For example, if topic.prefix is cdc, database.server.name is mysqldb, and the table is users, the topic name would be cdc.mysqldb.users. Example using Kafka console consumer.sh *. Troubleshooting * Kafka broker configuration * The most common issue is that the Kafka broker's auto.create.topics.enable setting is not set to true, or that the brokers haven't been restarted after the configuration change. Connector configuration * double check the Debezium connector configuration in the UI, paying close attention to the database.server.name, topic.prefix, and table.include.list properties. Kafka Connect logs * examine the Kafka Connect worker logs for errors or warnings related to topic creation. These logs often provide valuable clues about why topic creation is failing. Permissions * ensure that the Kafka Connect worker has the necessary permissions to create topics in the Kafka cluster. Topic naming conflicts * if you already have topics with names that conflict with the automatically generated topic names, topic creation may fail. Code example, programmatic configuration. While the Debezium UI simplifies the process, You can also configure connectors programmatically using the Kafka Connect REST API. Here's an example using curl. Replace the placeholder values with your actual configuration details. This curl command sends a post request to the Kafka Connect REST API endpoint to create a new connector named mysql connector with the specified configuration. Security considerations *** access control ** restrict access to the Kafka Connect REST API to authorized users and systems. * secrets management * avoid storing database credentials directly in the connector configuration files. Use environment variables or a secrets management system to securely store and retrieve credentials. * topic permissions * configure appropriate ACLs, access control lists, in Kafka to control who can produce to and consume from the automatically created topics. Conclusion ** Configuring topic auto creation with Debezium UI is a valuable technique for simplifying and automating your CDC pipelines. By properly configuring both Kafka brokers and Debezium connectors, you can streamline the ingestion of data from your source databases and reduce the manual effort required to maintain your data streaming infrastructure. Remember to prioritize security and follow best practices for production deployments. I hope this detailed tutorial helps you successfully configure topic auto creation with Debezium. Let me know if you have any other questions.